So welcome to the channel guys. Now we are going to discuss this step by night problem of GFG problem of the day. So I had opened the problem. So we are going to read out the description of the problem first of all. So the name of the problem is step by night. And night mean horse in chessboard, like that plays the role of which horse on chessboard who run two moves in a particular direction, then one moves in 90-degree opposite direction to it. Okay, I'm explaining it, or you can do it Google if you don't know about it. So we are given a square chessboard and the initial position of the knight, and we have also given a position of a target, and we have to find out the minimum. Yeah, focus on this one. Minimum steps a knight will take to reach the target position. So and the array is one based indexing. So okay, so like here 4 and 5. So 1 2 wait a minute. Okay, 1 2 3 4, fourth and fifth is the fifth column. So this is our knight and this is our target 1 comma 1. So our knight will take a move, can take a move two steps in this direction, then one step can be here after one move, or can be here. It can be here after one move, or can be here. It cannot take two steps in this direction. So we neglectify the steps in this direction, and it can be here, like two step here, then here, two step here, then here. And we have to sort it out how many steps will it take, minimum number of steps, so that our target it will reach to our target. Okay, so focusing into the code. Not so complex code. It has a simple code. So we are given a vector k, and k has the k is equal to 4 5 here. We are given vector t 1 1, the coordinate of target, and a int n, the boundary limit of our chessboard. So what we can do, we store a1 into k1, and b1 is equal to k1. Oh sorry, a1 is equal to k0, b1 is equal to k1. Similarly, x is equal to t0, y is equal to t1. I store the coordinate in a1, b1, x and y. Then I took a q of vector in type, and I took a dp of n plus n size, a 2D dp of n plus 1 size, because if I had I have traversed a particular index, and if I like from here, when I come here, and when I am iterating this particular index, then I will iterate it again, and this will make my cycle, and it will give me really for a huge number of n, like n can be vary from 1000. So for n is equal to 1000, it will give me a cycle which can give me a really. That's why I use dp, and if dp and I mark dp a1 b1 is equal to 1. A1 b1 is the index where our knight is at the current position. So I will mark it as 1, and our knight will cannot come on this position again. Okay, so I just push back a1 comma b1 is the coordinate, and 0 is the steps for reaching this particular coordinates from our this coordinate. Okay, so because initially we are at for a1 comma b1, so the number of steps required is 0. I again took a vector of int v. Uh, it is not necessary. I took I took TP. It is not necessary at all. I don't use it in my code. Yes, I don't use it. I just I don't know. I write it. So we run a while loop. Uh, sorry guys. So we run a while loop while q is not empty, and we store the first coordinate in A, second coordinate in B, and the number of steps taken to reach this coordinate is equal to C in C. So and then we just q dot pop. We do q dot pop. We remove that element, that coordinate element from our q. And if our a is equal to x and b is equal to y, means we have reached the target coordinate, then we just return the C. Okay, and now we will check the conditions. We will check the condition like in a minus 2. A minus 2 means a minus 2 in this index minus 1 and plus 1. Now wait a minute, my battery is around. Okay. So a minus 2 in this index, then I will do minus 1 and plus 1. Then I will check I it the my coordinates will always be from 1 to n. So it always be greater than 0 and always be less than or is equal to n. I for a minus 2 I check it for greater than 0 only, because if I substitute, because my a is less than or equal to n, and if I subtract something from it, then it will always be less than or is equal to n. Similarly, my b is greater than 0, and if I add something in my b, then it will always be greater than 0. So I just check when I do minus operation, then I will just check for greater than 0, and when I am doing the plus operation, then I just need to check if it is less than and is equal to n. So first I check a minus 2 and b minus 1, like a minus 2 and b minus 1, a minus 2 b plus 1. Okay, this condition covered. And my dp of that coordinate should be equal to 0 unless it make a cycle. Then what we do, we mark we mark the dp as 1, and we push that coordinate. Wait. Okay, we push that coordinate into 1 and do c plus 1, because the number of steps here is 0, then here is 1 1 1 1 1 1. The number of steps for reaching any of any of this and this position is equal to 1. So now for doing this to a plus 2, a plus 2 means here b plus 1 here, b minus 1 here. Again check it, dp should be 0 and it should be in the boundary limit. Then I will check for b minus 2, like b minus 2. How b minus 2? B minus 2 here a minus 1, here a plus 1. Similarly b plus 2 above, plus 1 here, minus 1 here. So I will check for it, and my whose condition is satisfied, I just push back in the queue and make my count, make my dp of that particular index is equal to 1. And if I found the index is equal to my my target vector, then I just return c. This will never work, this will never work, because there is at least a single perfect solution for me always. So I just check it, you can see it just work out. You can see it is problem solved successfully. All tasks have passed, time taken 0.1. So guys, this is the solution. I show you again. So guys, I hope you like it, and if you like it, then please subscribe the channel and show the other videos on my channel also, which I had uploaded related to GFG and late code daily problems. And in future I will continue to upload these problems. So I request you to subscribe the channel, because in future you will find many amazing content here related to coding. So thank you for watching this lecture guys. Thank you.